Welcome to my clock rack. This mini rack is the culmination of many months of effort putting a lot of different things together, and it still is going to be many months before I would consider it anywhere near complete. But there's some interesting stuff in here, and rather than wait another 6 months before I do a full video on this thing, which I will do at some point, I wanted to talk about why I'm building this, what it does, what it's good for, and the many things that I do not know yet that I built this thing to find out. This is a clock rack. That's what I'm calling it. It's a mini clock rack, more specifically. And it has, right now, 3 GPS-backed clocks and one very not GPS-backed clock that you might have seen if you watch Big Clive. He made one of these. I saw that video and I'm like, I want to build one of those too. Plot twist, this is a terrible clock, but it's already better than most of human history in terms of clock quality. But yeah, let's start with talking about the hardware in this, and then I'll tell you what's happening here, because you might notice some things blinking. Blinking lights are always fun, but it's also a lot more fun if you have a purpose behind them. So starting at the top here, this is something that I have not covered on the channel before. This is a box from NetTime Logic with an FPGA inside. And do you see all those blinks? Those blinks are pulses per second. If you pause the video, well, don't pause the video because you can't see the pulses every second. You'll notice that there's different rhythms to these pulses. That's something that we'll get into at some point. I'm not going to talk about why those rhythms exist or how we measure them, but I will mention that each of these little cables, these are little coax cables. Coax is kind of the industry standard for timing signaling. These cables all come out of devices. Like, for instance, this one is coming out of this little Switchberry, a Raspberry Pi clock and switch. And it goes into this input, which is PPS2. PPS1 goes down there and around the back into this guy. This is a microsync that I picked up at NAB from Mindberg, so thank you to Mindberg for sending this along for testing. And then there's also, that's into PPS1. PPS3 is this guy here, and I'll show you why this is not a great clock. Although it's not a bad clock, and I'll tell you why that's the case when we look at the data in a little bit. But then this last one up here, this is a reference. The reference is coming down to this guy, which is a calibrated rubidium GPS frequency reference. And it just has one little output here, and all that output is doing is outputting one pulse every second whenever the GPS satellites that are way up in the sky above us, I have an antenna outside that is feeding into these. I'll come around the backside and show you that in just a second, but let's finish the front here. So there's that Pi. This is a little mini PC that I'm using to monitor everything, and it is using this PoE device from WizPi that gives PoE power to my Jet KVM, which lets me remote control everything, and that way I can monitor what's going on through that NetTime Logic box. But here on the back side, I have a PoE switch to power some devices, I have a power strip to power other devices, and then this is one of the most important parts of this rack. It's a little GPS source GPS distribution box. I don't have a really clear picture of that. I'll insert a picture or a little clip of the same box. I have 3 of these now in the studio, all sharing a signal from my GPS antenna outside, because in the studio here, this is like there's one metal layer in here, and then there's another metal layer above it of the roof of the building. And there's another, actually there's 3 metal layers, because there's a roof, and then the building roof for sound isolation. So I could not get GPS inside of this space. So I have a GPS antenna outside, and right now that antenna goes here, and then it goes over on the floor, you can see down there, over to another distribution box, goes up through the ceiling, over here into the rack room, and down to my other GPS splitter. And if you look closely at these GPS cables that I'm using, you'll notice that I have labels on them. This one says 15 meter SMA. So every cable that I put in here, I label how long it is, and I'll talk about why that's important in a minute. But we're not getting deep into the time theory here. I just wanted to show this rack and what it's doing. So let me go over to the computer that I'm remote controlling through this Jet KVM. We're going to log into this one, and this is a time stick. It's not in use right now, but I'm going to be doing some PTP testing. And this little guy lets me do that via USB on any computer that can install the driver for it. But yeah, I don't need that right now. But you'll notice that it has a little SMA output here. See that little screw-in header? That is for one of these types of cables, so I can put it into here and measure the PPS through my network and see how my network is doing. That's one of the reasons we're building the Switchberry, is to have a low-cost, well, low-ish cost, network PTP hardware support for a switch that you also can manage and control. Anyway, that's going to be another video. There's a lot of videos on this that I've been working on that someday I will get to. But yeah, let's go over to the computer and check out the software that I have going. Okay, now you'll notice that this is blinking. One time every second it blinks. That's every time there's a pulse it comes in. This is the interface to show you what's going on through that NetTime logic box. So see this, it's sending data out and getting data back through that FPGA. So let me go back over to the PPS tab. This is showing PPS. You'll notice that there's a green bar down here that keeps going down, 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 and I've actually recalibrated this a bunch of times. And what this is showing is the oscillator on that free-running little clock that's at the bottom of the rack on the desk. That clock's oscillator is going out of alignment with true 1 second time, like the whatever the hyperfine transition of the cesium atom. That is going down, and that just means that the quartz crystal that's used in there, that little cylinder, is not super calibrated. It's not a temperature compensated oscillator. It's not a oven controlled oscillator. It's just a plain old quartz oscillator, and a cheap one at that. So yeah, and temperature changes will change this too. So what I'm going to do is take that out of the mix and show you what I'm really measuring here. And eventually I will be doing more clocks that don't use GPS for their timing. But let me go to change configuration, and we're going to turn off that discrete clock, the one that just has its quartz crystal. And click done. Now you can see something that's a little bit more interesting. If you look over here at the graph, it has 0, 20, 40, 60, 80, 100. So this is plus or minus 100 nanoseconds of time sync. And you'll notice that there's two lines here. One is very faint. I should probably make that darker. See that faint gray line there and the red line? Those are pretty much in alignment. But there's another one that's blue, and that's it goes up and down. Sometimes I've even noticed it goes like down across in this way. So the red line is the microsync, which is an expensive time server from Mindberg. The blue one is the Switchberry, which has a cheaper temperature compensating oscillator. It might not even have that. I don't remember which version I have in the rack right now. But anyway, you can tell that there's something a little bit off there because it goes up and down, and probably the control circuitry is not quite as robust, but it is still within 80 nanoseconds of GPS true time. And the gray one is the rubidium reference that is also disciplined by GPS. That means that it uses GPS to say, okay, pulse, pulse, pulse. And the GPS satellites are extremely accurate, down to, I don't know, plus or minus 30 nanoseconds with the GPS receivers that we have here. Probably even better than that with the one that's in the Calnex. But anyway, this is basically letting me compare all the clocks, and I can see this is end to end from the GPS signal into the clock and through its output to a PPS output. And this is letting me compare the quality of the clocks, and over time what I can also do is unplug GPS and see how the holdover is and whether the time kind of goes away or stays pretty close. With rubidium, it should stay pretty close to that for at least a long period of time until it starts drifting. But with cheaper oscillators, it usually would go very far off pretty quickly. So I'm not going to get too deep into the weeds and math and stuff because that's something that I need to do in future videos, but I can zoom out here and see that this oscillator that's on the Pi that's disciplined by GPS is a bit high, so I could probably calibrate it down a little bit. I'm not accounting in the Pi for the distance of the cabling. And cabling, a nanosecond is like 1 foot or so, somewhere around that, in coax cable. So you have to account for that delay from the GPS time into real time. So I might compensate that at some point, but right now you can tell that this oscillator is just not quite doing it compared to the extreme accuracy in the microsync compared to the rubidium. But there's also the ability to check, like, how far off am I usually? And it looks like the Pi is generally somewhere around 65 nanoseconds off. So I could calibrate that. And in fact, I will do that really quick just for fun. So the Pi is, let's see, that'd be 60. And fix that, and let's see, yeah, so now it's down there closer to the other two. This is one of the fun things is with clocks, you observe things for a long period of time, and then you adjust, and then you observe things again. And what I'm finding is there's a lot of math, there's a lot of patience, and there's a lot of fun mysteries. Like if you mess with the cabling, you'll actually see differences. Or if the temperature in the room changes, you can see differences, especially with things that are not oven controlled and atomic. But yeah, that is the clock rack over here, and I am working on it. I have it in a state where I can start doing productive testing. And a couple of things that I'm trying to figure out is the power situation. I also am talking to Master Clock about getting one of their clocks in here to start testing it as well. Because eventually I have a few fun projects in mind for all this. But for now, I'm just trying to learn the ins and outs of time measurement, precision time measurement more specifically, and how to distribute good time through many different methods before I can start saying anything intelligent about PTP and other things like that. I've used them. I've used PTP and NTP quite a bit in the past, but a full understanding of it is something that takes a lot more time, ironically. Anyway, that's all for this video on Level 2 Jeff. I will see you next time.